Welcome to Bhardwaj Gurukul. Today's chemistry lesson is all about understanding the basic grammar of science, the language of chemistry. Just like every language has letters, words, and sentences, chemistry has symbols, formulae, and equations. Let's decode them together. Laws of motion chapter from Physics Class 9 explained, link in I button. If you are new here, don't forget to like and subscribe to our channel and share this video with your friends. So, what we will learn in this video: symbols, how to make formulas, how to balance equations, how to calculate molecular mass, how to calculate percentage composition of any given element, what is empirical formula, and what are radicals and valence.
Language of chemistry. So first you have to remember all the elements in sequence till 20. Their atomic number and their atomic mass is not important, but you still can memorize it. So hydrogen atomic number 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, and calcium 20. So now let's talk something about atom. So atom has shells KLMN. Then these are further divided into SPDF, which are the subshells which are not a part of the syllabus right now. And these orbits, shells, and subshells contain electron. So they revolve around the nucleus in the orbits and inside the shells. So you can have a look at the diagram. The nucleus contains neutron and proton. Proton has the positive charge and neutron is of course neutral. And K, L, M, and shells are there. Shells are also called as orbits, and electrons revolve around here. Now, what is electronic configuration? Distribution of electrons in the shell or subshell are called as electronic configuration. So we have four shells K, L, M, and N. The K shell can have maximum 2 electrons, the L shell can have maximum 8, the M can have 18, and the N1 can have 32. More than 8 electrons can never fill in the outermost shell. So you can never fill more than 8 electrons in the outermost shell. So let's have a look at the first 20 elements electronic configuration. Hydrogen only 1, helium 2, from lithium we have 2 electrons in the K shell, and the third one goes into the L because the K shell cannot accommodate more than 2 electrons. Beryllium 2, 2, boron 2 and 3, carbon 2 and 4, nitrogen 2 and 5. Oxygen 2,6, fluorine 2,7, neon 2,8. Now if we look at sodium, 8 electrons or more than 8 electrons can never fill the outermost shell, so the ninth one will go in the M shell, so it will become 281. Magnesium 282, aluminium 283, silicon 284, phosphorus 285, sulfur 286, chlorine 287, argon 288, and in the potassium the 19th electron will go in the nth shell, so it will become 2881, and calcium 2882. Now let's talk about cations. What are cations? They are formed when electrons are lost by elements. Valence shell or outermost shell, so the number of electrons should be 1, 2, or 3. So if any element has 1, 2, or 3 in the last shell, in the outermost shell, then it is said to be cation or a metal. So cations always lose electron and form positive ions. Example, metals. Now let's look at some examples. If we look at sodium, so the electronic configuration will be 2 and 8 and 1. So the outermost shell contains 1 electron. So Na plus, it will have plus 1 charge, and it is a cation because it is having a positive charge. Second, calcium. Electronic configuration is 2882. The outermost shell has 2 elements, so the charge will be +2, so calcium +2. Now let's talk about anion. They are formed by gain of electrons. Number of electrons in valence shell should be 5, 6 or 7. They are negatively charged, they are non-metals. So if we have to calculate the charge on anion, then number of valence shell electron -8. Now let's look at some example. Chlorine. Electronic configuration would be 287. So as it contains 7 electrons in its outermost shell, so it is anion. But if we have to calculate its charge, then we will use the above formula. So 8 minus 7 will be 1, so it will have -1 charge, so it will become chlorine negative. If we look at nitrogen, electronic configuration will be 2, 5. So 5 minus 8 will be 3, so it will have -3 charge. Elements having 8 electron in their valence shell have 0 charge on valency, that is the noble gases. So hydrogen, lithium, sodium and potassium have +1 charge. Beryllium, magnesium, calcium and barium have +2 charge. Boron and aluminium have +3 charge. Nitrogen and phosphorus have -3. Oxygen and sulfur have -2. Fluorine, chlorine, bromine and iodine have -1. And all the noble gases will have 0 charge. So if we talk about variable valency, so iron possesses variable valency in the form of ferrous and ferric. Copper also possesses it, cuprous and cupric. Sn means your tin, so it will be stannous and stannic. Hg is your mercury, so mercurous and mercuric. And Pt is your platinum, so platinous and platinic. So let's have a look at some common anions which will be used in this chapter. SO4 2- is sulfate, SO3 2- is sulfite, S2- is your sulfide, NO3 2- is your nitrate, NO2- is your nitride, N3- is nitride, CO3 2- is carbonate, HCO3- bicarbonate, PO4 3- phosphate, PO3- phosphide, P3- phosphide, OH- hydroxide, Cl- chloride, Br- bromide, I- iodide and F- fluoride. Next, Zn2 2- zincate, PbO2 2- plumbite, Al2- metaluminate, CH3COOH- acetate, Cr2O7 2- dichromate, MnO4- permanganate and NH4 plus ammonium. So you have to learn and memorize them all. Now we will learn how to make formula by the crisscross method. So if we have to make the formula of aluminium hydroxide, we know the formula of aluminium and hydroxide. So Al3 plus and OH minus, so they will exchange their charge. So Al will become positive, means 1 will come over here and OH3 will have the 3. Next, magnesium hydroxide, Mg plus 2 OH minus, plus 1 will come over here and 2 will come over here. Calcium hydroxide, Ca plus 2 and OH minus, so Ca will have 1 and calcium hydroxide will have 2. Sodium hydroxide, Na plus OH minus, so Na will have 1 and OH will also have 1. Ammonium hydroxide, NH plus 4 and OH minus, so NH OH ka whole 4. Copper hydroxide, Cu plus 2 OH minus, CuOH whole twice. Zinc hydroxide, Zn plus 2 OH minus, ZnOH whole twice. Lead hydroxide, Pb plus 2 OH minus, PbOH whole twice. Ferrous hydroxide, FeOH ka whole twice. Ferric hydroxide, FeOH whole thrice. Sodium nitrate, NaNO3. Potassium nitrate, KNO3. Ammonium nitrate, NH4NO3. Silver nitrate, AgNO3. Magnesium nitrate, MgNO3 whole twice. Calcium nitrate, CaNO3 whole twice. Copper nitrate, CuNO3 whole twice. Zinc nitrate, ZnNO3 whole twice. Lead nitrate, PbNO3 whole twice. Sodium nitrate, NaNO2. You have to be very specific with the nitrate and whatever. potassium nitride KNO2, ammonium nitride NH4NO2, sodium carbonate Na2CO3, potassium carbonate K2CO3, magnesium carbonate MgCO3, calcium carbonate CaCO3, lead carbonate PbCO3, zinc carbonate ZnCO3, copper carbonate CuCO3, sodium bicarbonate NaHCO3, potassium bicarbonate KHCO3, calcium bicarbonate CaHCO3 whole twice, magnesium bicarbonate MgHCO3 whole twice, sodium sulfate Na2SO4, potassium sulfate K2SO4, calcium sulfate CaSO4, magnesium sulfate MgSO4, zinc sulfate ZnSO4, copper sulfate CuSO4, lead sulfate PbSO4, sodium sulfite Na2SO3, potassium sulfate K2SO3, calcium sulfite CaSO3, magnesium sulfite MgSO3, sodium bisulfite NaHSO3, potassium bisulfite KHSO3, calcium bisulfite CaHSO3 whole twice, magnesium bisulfite MgHSO3 whole twice, sodium oxide Na2O, potassium oxide K2O, magnesium oxide MgO, as the plus 2 and minus 2 will get cancelled, so it will become MgO, calcium oxide CaO, zinc oxide ZnO, copper oxide CuO, lead oxide PbO, aluminium oxide Al2O3, calcium oxide CaO, copper oxide CuO, ferrous oxide FeO, ferric oxide Fe2O3, sodium chloride NaCl, potassium chloride KCl, calcium chloride CaCl2, lead chloride PbCl2, ferric chloride FeCl3, copper chloride CuCl2, magnesium chloride MgCl2. Acids. Those substances which produce hydronium ion or hydrogen ion in aqueous solution are called acids. Means those substances, when they are mixed in water, they either produce hydronium ion or hydrogen ion. They are called as acids. Example: hydrochloric acid, nitric acid, sulfuric acid, acetic acid. Acidic radicals. They are the atoms or groups of atoms having negative charge. Example: chlorine, nitrogen, sulfate. Bases or alkali. Those substances which produce hydroxyl ion OH- in the aqueous solution are called bases. Example: metal hydroxide, calcium hydroxide, potassium hydroxide, sodium hydroxide. Basic radicals. They are the atoms or groups of atoms having the positive charge. Example: sodium, potassium and ammonium. Why should an equation be balanced? A chemical equation follows laws of conservation of mass, so that's why it should be balanced. What information is conveyed by a balanced chemical equation? It conveys the result of chemical changes, it conveys the chemical composition of the respective molecules, it proves law of conservation of mass. Chemical equation. It is the symbolic representation. Symbolic representation is the keyword, using the symbols and formulas of the substances involved in the reaction. Atomic mass unit AMU. It is defined as the 1/12th mass of carbon atom. Relative atomic mass of an element is the number of times one atom of the element is heavier than 1/12th times the mass of one atom of carbon. Relative molecular mass. The relative molecular mass of a compound is the number that represents how many times one molecule of the substance is heavier than 1/12th times the atoms of carbon. So, calculation of relative molecular mass. If we have to calculate the molecular mass of H2, means hydrogen, so we know that the atomic mass of hydrogen is 1. So as there are two atoms, so 1 plus 1, that is 2 AMU. O2, so the oxygen has mass 16, so we have 2 atoms, so 16 plus 16, 32 AMU. Similarly, nitrogen, N is equals to 14, so 14 plus 14, 28 AMU. H2SO4, so we know that hydrogen has the atomic mass is 1, sulfur has 32, and oxygen has 16. So 1 into 2, as there are 2 atoms, then 32 into 1 as there is only 1 atom of sulfur, and 16 into 4 as there are 4 atoms of oxygen. So we'll sum them up, and 98 AMU will be the molecular mass. Similarly, HNO3, hydrogen is equals to 1, nitrogen is equals to 14, and oxygen is equal to 16. We have 1 atom of hydrogen, so 1 into 1. Nitrogen also we have 1, so 14 into 1. Then we have 3 oxygen atoms, so 16 into 3, 63 AMU will be the whole relative molecular mass. Now Na2SO4.10H2O, so molecular mass will be 14 into 2, as there are 2 atoms. Sulfur we have 1, so 32 into 1. Oxygen there are 4, so 16 into 4 plus 10. 10 is the whole mass of H2O, so you cannot just multiply it with hydrogen. It is multiplied with hydrogen as well as oxygen, so 10 will be there as so H2 means 2 into 1, and oxygen 16 into 1. We will solve them, and 132 AMU will be the answer. Now let's calculate the percentage composition. Calculate percentage of nitrogen in urea. So this is the formula given. So first we'll calculate the molecular mass as we did it earlier. So 14 into 2 plus 4 into 1 plus 12 into 1 plus 16 into 1. We'll solve it. We'll get 50 AMU. Now we have to calculate the percentage of nitrogen in this much AMU. So we will calculate the amount of nitrogen given. So there are 2 nitrogens given, so the whole mass will be 28, as one atom's mass is 14 AMU, so it will become 28 upon 60, which is the whole mass, into 100, because we have to calculate the percentage. We'll solve it. We'll get 46.67%. Second question, Na2CO3.10H2O. We have to calculate the mass of H2O. So molecular mass we'll calculate it. We'll get 286 AMU. We have to calculate the mass of H2O, which will be 180 upon 286 into 100, which will give 62.93%. Now let's do empirical formula. C6H6. So we'll write C6H6. We'll write all the numbers given over here. We'll simplify them, which will become 1:1. So the empirical formula will be CH. You just have to simplify it. Another question, C6H12O6. So it will be 6:12:6. So on simplifying, it will come as 1:2:1. So the empirical formula will be CH2O. Third part, CH3COOH. So this will be 2:4:1. We'll simplify it, 1:2:1. So the formula will again come as CH2O.
Summary and exam tips. Symbols are the alphabets of chemistry. Formulas, how should you form formulas using valency and radicals. Equation, how do you balance them, reactants given products. Always balance equation. Practice using the periodic table for radicals and valency. Tip: memorize radicals, practice writing formulas, and balance at least 5 equations daily. Great work! You have now mastered the language of chemistry. If you enjoyed learning with us, do like, share, and subscribe to Bhardwaj Gurukul for more ICSE Class 9 Science Made Easy. Thanks for watching.